Hello everyone. Let us discuss about this concept, that is Coulomb force in vector form. How to write Coulomb force in vector form. In the last session we have discussed about the electrostatic force of attraction or repulsion between the two charges is directly proportional to product of the charges and inversely proportional to square of the distance between them, and the formula is given by 1 by 4 pi epsilon naught q1 q2 divided by r square, where what is the value of 1 by 4 by epsilon naught? It is 9 into 10 to the power 9. 9 into 10 to the power 9. Now, if you consider how to write the Coulomb force in vector form, let us consider here. There are two charges. Let me write here. Let me utilize the complete space possible. So let's consider the force acting on second charge due to first charge is outwards. The force acting on first charge due to second charge is towards left. Okay, and let me write the displacement vector between these two is r12 in this direction, or r21 from r2 to r1. Displacement vector r21 in this direction, r12 in this direction. Now we need to write the Coulomb force in vector form. Coulomb force in a vector form because force is a vector quantity, alva. Now F12 ಬರೀತೀನಿ. 1 over 4 pi epsilon is a constant. Charge is a scalar quantity, so ಅದನ್ನು ಮುಟ್ಟೋದಕ್ಕಾಗಿಲ್ಲ. Divided by r. So F12 direction ಅಲ್ಲಿ displacement vector ಯಾವುದಿದೆ? F12. In the direction of F12 we have r21. So r21 cap ಅಂತ ಬರೀತೀವಿ. In the direction of r21 we have F12. Or you can also write F21 is equal to 1 over 4 pi epsilon naught q1 q2 divided by, so this is r square, right? R square. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ? r12 ಬರೀತೀವಿ when the force was in the direction of r12 we have F21. Simple is that. This is the simple way to write the Coulomb force in vector form. Okay, so we know that the unit vector r cap can be written as r vector divided by r. R vector divided by r. ಅದನ್ನ ನಾನು ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದೆ, ಏನು ಬರುತ್ತೆ? F12 vector is equal to 1 over 4 pi epsilon naught q1 q2 divided by r vector 21 ಬರೆದಾಗ divided by r ಬರುತ್ತೆ. So r into r square is r cube. When you write unit vector, no problem. When you write normal vector, you have to write r cube here. Similarly, F21 is equal to 1 over 4 pi epsilon naught q1 q2 divided by r cube in the direction of r12. So r is the distance between 1 and 2, r2 and 1. Magnitude, that's why I have written it as r12. You can write r21 here also. Okay, r21. Or you can write like this also. Magnitude of r21 whole square or whole cube. Okay, next. We have one more way to write the Coulomb force, the standard form to write the Coulomb force. For that, I will take a three-dimensional concept here along x-axis, y-axis and z-axis. Let's consider a charge here, q1, one more charge here, q2, q1 and q2. So q1 is at a distance, how much? r1 vector. q2 is at a distance r2 vector. So force acting on q2 is in this direction, F21. Force acting on q1 is F12. They are equal and opposite in direction. So distance between these two is given by, this one is r12, this one is r21 ಅಲ್ವಾ. ಅದನ್ನ r1 minus r2 ಅಥವಾ r2 minus r1 ಅಂತ ಬರೀಬಹುದು. We can write it as r1 minus r2 or r2 minus r1. So let me write it as r1 vector minus r2 vector in this direction. That if I substitute here, what do you get? f12 1 over 4 pi epsilon naught q1 q2 doesn't vary, but this distance is r1 minus r2 magnitude. So we have to take r21, right? So you can take r2 minus r1 also. r2 minus r1. So here r2, here cube, here it is cube, r2 minus r1, r2 minus r1. Like this also we can write, or f21 is equal to r1 minus r2 also we can write by using triangular law of vector addition. Okay, this is how we write the Coulomb force in vector form. Now we'll discuss about special cases.